Hello everyone. So in the last video we have changed the values of this analog outcome. Hence we changed the value of the output voltage, and we have seen whether this LED's brightness is changing or not. In my simulation environment I was not able to see a one, but for the sake of the video I have to go with this environment. But I hope you have tried this with your real Arduino and a resistor and LED, and you might have noticed a clear change, guys. Clear brightness change. And I'm quite sure, not quite sure, I'm actually sure there is obviously a voltage, brightness change, because I have done it with real Arduino already. So if you don't find a proper change with this current code, so what you can do is you can go little down. You can go for 180 value, that is a more lesser voltage. That will give a more less voltage than 3.9. so you will understand what 3.9 if you watched the previous video. So again we'll start the simulation and see, because this video is the continuity of the previous video. So the LED is still on, but the brightness is actually low, but here I am not able to see this, since this is the environment. But you can simply try it with your real Arduino and you will obviously see the brightness is low, it is dimming. So I will further slow down, go for less voltages. Let's go for 140 and see what happens. So here also my LED is on, but obviously the brightness should be lesser than that previous. So let's go for 100. So I hope what I'm changing, guys. I'm just changing the analog value. It's obvious. And see, the LED is not even switched on. So this value is not enough to switch on the LED. This analog value, and the voltage coming from this analog value is not enough to switch on the LED. So you also can try and find out around which value the LED cannot be even switched on. So you decrease the voltage using that analog values, and the LED's brightness is going down in your real Arduino. And when you are going to a particular analog value, the LED is even not switched on. So you say, with this voltage we cannot even switch on the LED. So more than this particular voltage, we can slowly increase the brightness up to the maximum at 5 voltage. Guys, you get this. So for this moment, so you can find your own one. What is the exact analog value where the LED is going off, and you can let me know in the comments. For the moment I am just taking the 100 and see what is the voltage value. So what is the equation, guys? I have to divide 5 by 256 and multiply it by 100. Then I will get the particular voltage value. So actually I have to multiply it by 101, because when I am saying 100 as the value, output value, actually the number of units is 101 units, isn't it? So you can understand this if you watch the previous video. So I have to do this thing and multiply by 101. So I will quickly do it. I'll go for 5 by 256 and I'll multiply it by 101. 1.97 voltage. So 1.97 voltage, by any means is not enough here to switch on the LED. You get it, guys? That's nice, right? So what you can now do is you take this code, and you slowly decrease the LED values manually, like this. So you can have a small delay, let's say 100 microsecond delay, very small delay. And again what you can do is, so this will give 5 voltage. Again you can give an output of a slight delay. Guys, let's say a slight, not delay, slight lower voltage. So after 100 millisecond I'm going to decrease the voltage amount. I will go for 250, not 250, yeah, 250. So again delay 100, and again I will decrease by 5. So you can decrease it slowly like this, guys, but it will take a lot of lines to write the code. Maybe 245, like this. You can keep writing until it becomes 0. It takes a lot of lines of code. Maybe you can copy paste it, but still this is a pain. Guys, so you can go down like this and see whether this is really changing, but it's a lot of line. So if you want, you can decrease the distance, like I have decreased it by 5 analog values, you can try 10 or 20, so that you can have only few lines of code. Okay, you can write that, try like that. So if you are decreasing by 20, if I am correct, in 10 or 15, within 10 or 15 lines you can reach the 0. I mean, you can totally go off. Okay, so let me try that also. 20, let's decrease by 20, 15, 205. Am I correct? 195, 175. Okay, so it looks like it's going to take your time. Okay guys, so $175, okay, 155. So guys, just to save your time, I have quickly done this. So I have started from 255 and I decreased by 20 analog units. Okay, so 20 analog units means how many voltage would it be? So let's check that out. Okay, so we know 1 analog unit means, okay, let's see this, 256 analog units means how much? 5 voltage. Okay, so what is the value of 20 analog units? So what I have to do, I have to divide 5 by 256 and I have to multiply the answer by 20. Okay, then I will know the total analog voltage value for the 20 units because the difference is exactly 20 units, right? 20 units. So what I will do is I will do this quick calculation. If you don't understand the calculation, just don't worry guys. Okay, so it is 0.39 voltage, right? So here, okay, if you don't understand this, don't worry, but you should understand this actually, right, if you properly follow up my videos. Okay, so 0.39 voltage is the voltage amount for 20 analog units. So what I am doing is I am decreasing it by 20 analog units. That means I am decreasing this output by 0.39 voltage. Okay, from 5 voltage to 0 voltage, I am decreasing by 0.39 voltage, very slow decrease. So in other words, I am decreasing the brightness by whatever the particular brightness for 0.39 voltage. Okay, I am decreasing the brightness at every 100 millisecond by that respective brightness for 0.39 voltage. Okay, so the brightness should slowly decrease for I mean in 100 millisecond delay time, and it should go off at a particular point, maybe here or here, we don't know, and then it should go up to 0. In an off state it should go up to 0, since 100 millisecond is a very slow time, so that will not take much time. And when it comes to analog write 0 voltage, then after 100 millisecond it will again suddenly switch on. Okay, and again it has to slowly switch off. Okay, slowly the brightness has to go off, right? So you can see guys, manually I have done this, but there are smart and nice way to do this in 2, 3 or 4 lines using some conditions or loops. Okay, we will study that later. Okay, so now I want you to understand what I have done properly. Okay, first, okay, so that is very clear to you guys. Okay, I am trying to decrease the voltage, okay, of this LED, so that I can decrease the brightness, I can dim the LED slowly. Okay, to decrease the amount of lines, I have changed the I have used the difference of 20 analog values. Okay, I can go for 5 analog values, but the number of lines will be a lot. Okay, so I will verify it and make sure there is error free. Okay, this is okay guys, so this is error free. I can try this out. What I want you to do is, you guys write this code and you can try with your own Arduino and LED before I even do the demonstration, and check it, because I am going to use a simulation environment, but you can do it with the real Arduino and LED, and you can let me know what is the output you are seeing. Really the brightness is decreasing up to switching up to 0 or not, you have to tell me. Okay, brightness is going down and the LED is going off at that point or not, you have to tell me guys. Okay, so guys, I will catch you up in the next video. Follow me up in the next video guys.